C7 exam practice questions. Got a reaction here which is mixing acid and alkali together. We've got temperature, start and end, and temperature change results. They ask us to suggest how we can modify the apparatus to reduce heat loss. We can put a lid on the beaker. We can change this glass beaker for a polystyrene cup, or we can insulate the outside of the beaker as well. Okay, B. Suggest what's important to mix the chemicals thoroughly to ensure all the reactants have reacted and to ensure the temperature of the solution is the same throughout, or the temperature is homogeneous. Which of these experiments is probably done on a different day? Well, it was 2 because it had a different starting temperature. D. Suggest why experiment 4 should not be used because it's significantly different to the other results. It is anomalous. Calculate the average, which gives us 7. Use the following equation to calculate the energy change for this reaction. They give us the equation. Okay, so all we have to do is put the temperature change in here. You need to remember that the 100 in this equation, which is the mass of liquid that's being heated, and in the experiment you can, if you look back, it's 50 centimeters cubed of acid and 50 centimeters cubed of alkali. So put those together gives us 100 grams. Okay, so that's where the 100 comes from. 4.2 is the specific heat capacity of water, and 7 is the temperature change which we've calculated here in E. G. Which of these diagrams represents our reaction? Well, it's diagram A because it's exothermic, it releases heat energy, products have less energy than the reactants. Question 2. Okay, so here we have vegetable oil, peanut oil, methanol and ethanol all being burned. The mass burned in each case is given and the temperature increase is given. They ask us to suggest that vegetable oil was the best fuel for producing heat, and that is because it releases more energy per gram when it burns. Well, how do we know that? Because the others raise the temperature by 6 degrees, 3 degrees and 10 degrees respectively per gram. Vegetable oil raises the temperature by 15. B. Suggest an environmental problem that could be caused when large amounts of vegetable oil are burned. Suggest how the problem could be overcome. Well, you're getting more smoke, which is going to be particulates as well as greenhouse gases, and that's due to incomplete combustion. So we add more oxygen when we're burning. That increases the combustion and reduces the amount of particulates that are produced. C. On this diagram, A represents the activation energy and the amount of energy given out during the reaction is B. Question 3. Decomposition of hydrogen peroxide. It's exothermic. They want us to describe what an exothermic reaction is. So we can say a number of things. It gets hotter. It releases heat energy to the surroundings. Also, the energy of the products in our diagram here is lower than the energy level of the reactants. We could also say bond breaking requires less energy than the energy released when new bonds form. So there's lots of ways that we can describe that. Okay, so continuing question 3. Use the graph to describe changes in the rate of reaction. We've not done this work yet. Okay, this is C8. But I'll go through it anyway for information. The reaction is very fast at the start. The steeper the line, the faster the reaction. The reaction slows down as it progresses, and then when it becomes a horizontal line, which is pretty much here, about 30 seconds, the reaction's finished. What is the total volume of oxygen collected? 21. Calculate the percentage yield. That's 21 divided by 25, which is the optimal. Times by 100 gives us 84%. Okay, electrochemical cells. Looking at different metals, chromium, copper, iron, tin, zinc. They give us a half equation for zinc. Zinc is oxidized, give a reason why. Oxidation is when an element loses electrons during a reaction. B, looking at the table, which one of the metals used is the least reactive? It's copper. How do we know that? Because every time a metal is coupled with copper to make an electrochemical cell, it gives its biggest potential difference or voltage. So anything paired with copper will give a higher voltage. Predict the voltage that would be obtained from a simple cell of iron and copper. So it's going to be 0.7 or thereabouts. Iron has a reactivity somewhere between zinc and tin. So the voltage it will produce with copper is between 1 and 0.4. So I'm guessing any value between those numbers would be acceptable. But you'd want to be closer to the halfway mark to be safer. Hydrogen fuel cells have been developed for cars. Overall equation for the reaction, and then the two half equations. Question 5. What type of energy is released by hydrogen fuel cells? It's electrical. And suggest 2 reasons why the UK government might encourage the building of more hydrogen filling stations. It's to encourage people to buy fuel cell powered cars. It makes their use more viable. There's no point in buying one and then you have to drive 100 miles to fill it up. So that will encourage people to buy more, and that will reduce pollution. Okay, we've got a number of these questions here. I like to write them like this. So bonds broken minus bonds formed. So it's the energy required to break the bonds, take away the energy formed or released when bonds formed. So we write out every single bond that's broken and we add those values together from the table above. Do the same thing for the bonds formed, and we take the bonds formed energy away from the bonds broken energy, and it gives us a value. So exothermic reactions have a negative value. Part 2, energy level diagrams. They just ask you to label them. You can see what I've done there. They're both the same, both exothermic. Okay, we've got some more of these. So we've got bonds broken, take away the energy when bonds are formed, and that gives us minus 93 for the first one. Explain why, in terms of bonds broken and bonds formed, the reaction is exothermic, because the energy needed to break the bonds is less than the energy released when new bonds are formed. Question 7. Right, on this one, we haven't gone through this in a lot of detail because I wanted to do this in the lab so we can have a go at the experiment, but I'm not sure when we're going to be able to do that. So key here is M in this equation here stands for mass, but it's not the mass of the alcohol that we burnt, it's the mass of the liquid that's being heated up, which is 50 grams of water. So it's the mass of the liquid that's being heated up that we put into the equation. Okay, so that is important. So Q is 50 multiplied by 4.2, which is the specific heat capacity of water, multiplied by delta T, which is the temperature increase, which is 16.4, gives us 3,444. Okay, another one of these. So bonds broken, take away bonds formed. Now on this one, you may have realized that this OH bond here isn't broken, and we form 5 new OH bonds on this side. Okay, so if you worked it out that way, that's perfectly fine. What I did here, just for simplicity, I broke all the bonds and then reformed them. Okay, it will still give the same value of minus 2761, another exothermic reaction. The reaction is exothermic, explain why, we've answered that one already. Complete the energy level diagram. Again, we've done those, so fairly straightforward. And we're done.